Hello, we are Senior Design Team 5 from the Biomedical Engineering Department, and our project is Improving Consolidated Implantable Satellite Tag Retention Elements for Cetacean Conservation. To aid in the conservation, satellite telemetry tags are used to acquire migration data on whales to minimize their contact with humans. The currently used tags shown here are approximately 15 centimeters long. These tags feature 12 retention petals that are 3.7 centimeters long, which are designed to keep the tag embedded in the blubber as the whale moves. The current tags last an average of 21 days, which is not long enough to get the data for a full migration season. The goal of our project is to increase the retention and extend the service life of the tags by altering its retention elements.
As our guide to our project, constraints were made on the increase of retention force that would be acceptable, as well as an upper limit on the tissue disturbance of the novel tag design, both of which compare to the current tag. Over several iterations, these were all the prototypes created. The artichoke designs were made to test the effects of multiple layers of petals on retention. The river anchor and circular petal designs changed the shape of the petals, making them broader and decreasing their number. And the screw designs modified the tag body itself to try and force the tag to be screwed out after insertion. Our design process started with modeling new designs using 3D modeling software. Then the retention elements of the new designs were cut out of 316 stainless steel sheets and welded onto sharpened steel rods 1/2 scale to the current tag. Once the prototypes were made, they were tested against the control tag with no elements, as well as a scaled model of the current tag. After each iteration of testing, data analysis was conducted and the tags were evaluated based on how well they met the objectives and constraints. The most promising ones were altered, and the process began again.
The prototypes underwent two different types of testing. First, they were tested for tissue displacement, or how much damage they would cause the whale upon insertion. This was done by inserting them into clay blocks and then using image analysis software on cross-sections of the block to measure maximum, minimum, and average tissue displacement. Then the tags were assessed on their retention capabilities. They were first set in ballistics gel and then removed from the gel at a steady rate using the MTS Acumen machine. This generated force versus displacement curves, which were then analyzed for maximum force to remove, as well as total energy for removal. This process can be seen on the right. Once the data was collected and analyzed, the tags were compared to the current tag to see if their performance met the design constraints. Seen here, below the horizontal red line, all of the tags met the tissue damage threshold, but only the river anchor and artichoke 2 designs met the retention increase requirement, to the right of the vertical line. However, the artichoke 2 decreased tissue damage, whereas the river anchor increased it. While the river anchor was still within the threshold, the artichoke 2's superior performance and retention, coupled with its decrease in tissue damage, made it the final design choice.
To extend the service life of satellite telemetry tags in cetacean conservation, this project evaluated several novel retention element designs. The Artichoke 2 final design improves the maximum force to remove and total energy to remove, while decreasing the cross-sectional area of the wound profile. Future projects could test this prototype in closer tissue mimics and under different loading conditions to further test how it would behave in real life. We would like to acknowledge Dr. Alex Zerbini at NOAA and Ariana Smees here at the BME department, as well as the M&M Machine Shop and the rest of the BME department here at Michigan Technological University.